We have seen all the loops and their control structures. Now it's the right time to jump into arrays. We know that arrays are used to store multiple values of same data type or even different data type, as we have discussed earlier. And we also knew array behaves something different when it is passed as an argument. Why it is behaving like that, or what exactly happens when you try to access array by a pointer or by array indexing itself. Let's have a look. Let's try to understand about arrays. Let's take an array for example. I have declared an integer array of size 10. So we know that the array indexing starts from 0, 1, 2 and so on. And if I want to access a specific element, for example this, it can be accessed with the help of its index. It can be accessed as a of 3. Before proceeding with arrays, I want you to understand one thing. Array name is generally mnemonic, which represents its address. And if an array was declared as such, let's say it starts at a memory location of 100, then A actually represents 100. Generally, if you take a normal variable A and if you assign a value of 5 to it, A will be having the value of 5. So whenever you write A, it represents 5. But if it's an array, it actually has its base address. As this array starts from the location 100, the name of the array represents the start address, which is 100. And you need to remember one term in specific while dealing with arrays, pointers especially, that is scaled operations. So whatever happens with arrays and pointers generally happen according to the scale. What are scaled operations? Let's try to understand it with the help of an example. Let's say A is pointing to 100 and size of integer is 2 bytes. And A is an array type of integer. So A is an integer array and it starts at a memory location 100, which is represented with A. Now A plus 1 will be modified as 100 plus 1 into size of A, which is integer. As it is 2 bytes in this case, it will be transformed to 102. If I write A plus 5, it will be transformed as A represents the base address 100 and 5 times the size of this data type. This data type is integer, which is of 2 bytes. So it represents 110. If A is a character array and let's assume A starts at a location 100, then A plus 3 represents 100 plus 3 into size of char, which is generally 1. So it will be modified as 103, whereas A plus 3 in this case will be modified to 106 if the start address is 100. This generally represents the scaled operation. If I have something as A plus K, that will be transformed as base address of this array plus K times the size of the data type to which A belongs. Now we all know that as array name represents its start address and it is used to perform scaled operations. If I want to access this location, I can actually access it with the help of indexing. We all know that. Let's recollect the pointers. If we have a pointer, it actually stores the address. Let's say pointer is storing the address of 100. Now, if I want the content at this address, I can get it with the help of dereferencing operator. So, star P will be transformed as content at address location 100. So, in this case, equivalent to 1. Similarly, as I have told you, the array name is mnemonic that represents address. So, if I want to get content at address, I will be using the dereferencing operator, which is star. And I can use star before the array name to get the content. So, we can even get this with the help of star A. If A is an integer array, it transforms to content at address location 100, which is 1 in this case. If I write A plus 3, we know that it is A plus 3 into 2, 100 plus 3 into 2, which is 106, and the content at this location, if I want to get the content at this location, it can be obtained with the help of a dereferencing operator before it. So content at this location is content at the location 106, which is 4. With this, if I want to access the content at a location, I can access it with index, or I can even access it with the help of array name by putting a dereferencing operator before it, as in this case. I think by now you might have figured out the reason for the strange behavior of arrays. It's because arrays name act as a mnemonic which holds the address of the array itself. Strange, right? Now let's try to analyze it more further by taking the help from pointers. We'll also see strings in the way. We all have seen there are two different ways until now to access any content. Suppose if I want to access this, I can access with its index, or I can access with the name of its array followed by a dereferencing operator. We have seen these two ways so far. Let's try to explore one more way where we try to make a pointer point to the first location of the array. So let's go ahead. I am trying to declare an integer pointer, and this pointer needs to store the address of the array. We know that this actually represents the address of array as A is an integer array. So we are trying to store the address in P. Now P is having 100 and let's say it is at a location of 500. We all know that arrays and pointers actually follow scaled operations. So as P is an integer pointer, if I write P plus 1, it will be transformed to 102. If I write P plus K, it will be transformed to base address of P, which is 100 in this case, plus K into size of its data type, which is 2. So 100 plus 2K. We also know that if we want to access the content of this location, we can use it with the help of a dereferencing operator. If you remember, P is actually pointing to the start address 100 in this case. Now I want to access this location with the help of this pointer. Then this will become P plus 1, P plus 2, P plus 3. So P plus 3 will be equivalent to 106, and I want to get the content at this location, which can be done with the help of dereferencing operator P plus 3. So dereferencing operator will be before this. P is actually equivalent to 100 and 3 times into size of int. So content at 106, which is 4. Now we found another way to access it with the help of a pointer, which can be accessed as follows. To understand these pointers and arrays together, let's take the previous example and let's assume P is pointing to the first location. So P is actually having the address of 100 and let's say it is at a location of 500. Let's target any one of the location. For now I am going to target this. It is an integer array which can be represented with A. So if I want to access its address, I can do it as follows. As P is having its address, I can reach this position by adding P plus 4. So 100 plus 4 times 2, which is 108. Okay, fine. Now with the help of a pointer, if I write P plus 4, I am pointing to this location. If I want to point to the same location with the help of array name, we know that A actually represents the base address 100, and if I add 4 to it, as it is a scaled operation, it will also point to 108. So A plus 4 is also pointing to the same location. And we know that this can be even accessed with index, let's say A of 4, and the address can be obtained with the help of an ampersand operator. So ampersand A of 4. So this also represents the address. Now if you see, all of these are representing the same thing. So we can write a statement as follows. P plus K equal to A plus K, where A is the array name and P is the pointer, and it is also equivalent to ampersand of A of K. All of this is actually representing the address. Now let's say if I am trying to find the content, it can be found with indexing A of 4, first approach, or I can use a dereferencing operator before the pointer, or I can use a dereferencing operator before the array name. All of these three are also equal. So A of K is equivalent to content at P plus K if P is a pointer pointing to its base address, and array name plus K because array name is a mnemonic. Now I think you have got a clear idea to understand pointers and arrays together. Now let's try to understand pointer arithmetic. I have declared a 2 pointers, suppose P and Q, and P I want to point it to the first location, which can be done with ampersand A of 0. This actually gives me the starting address, or it can even be given by A directly if A is an integer array. Now I want Q to be pointing to, let's say, this location 106. So I can write Q is equal to A plus 3, which will be 106, or I can even write it with the help of the address of its index by using an ampersand. Now P is pointing to this location and Q is pointing to this location. Let's try to see what are all the different type of operations that can be performed with the help of pointers and integers and pointers itself. If we see the operations, if you look at the operations performed between pointers and integers, I can actually add and subtract them. P plus 3, P minus 3. So if P is at this location, P plus 3 actually takes it somewhere to this location. Similarly, if Q is at this location, Q minus 3 actually takes it backwards. So addition and subtraction of a pointer with integer is possible, and you can even subtract 2 pointers of same type. That means if two pointers are actually pointing the same array, then you can actually subtract them, q minus p. It is also a scaled operation because we are performing the operation with pointers. Now q minus p actually results in, if q is pointing here, it actually results in 3, which is 106 minus 100 divided by size of data type, which is 2. So it actually results as such. If you just observe, the subtraction of two pointers actually represent the number of values that are between them. Now, to have a quick recap of things, let's try to look at all the possible operations. First is assignment of same type. If p and q pointing to the same array, then they are of same type, and p is equal to q or q is equal to p. This assignment is actually possible. And adding or subtracting a pointer and an integer, which actually moves the pointer forward or backward in an array. We have also seen this. Now, subtracting pointers of same type. Suppose, for example, you have two pointers p and q, and if they are of same type, we have discussed what is same type, then they can be subtracted as well. These are all the various operations that happens in terms of pointers. You need to remember one thing, if p and q both are pointers, only subtraction is allowed in between them, and also only if they are of same type. Addition, multiplication, all these operations cannot be performed within two pointers. It doesn't make any sense, right? Suppose, for example, if p is having a location of 100, q is having a location of 106, if you are trying to add it, it will move to some location, some random location, and if you are trying to access this value at this location, it will be garbage. Same in the case of multiplication, it makes it more worse. But subtraction actually gives the number of values that are between them. Strings are nothing but array of characters. So, if you have taken a character array, you can declare the string in this fashion. The only thing that you need to bother about when you are dealing with strings is it ends with null character. If it is a string, it actually ends with null character. If it is a character array, it need not have null character. But if it is a string, it need to have null character. If we just see, the space required for storing this string is actually equivalent to length of this string plus the space required for this null character. As the character is taking 1 byte, we are actually storing it in the respective locations in this character array. One more thing you need to remember while you are dealing with strings is, array can be modified, but a string can't be modified. If this is an array, if you want to change the value at this location, you can actually change it by accessing with a of 0, a of 1, a of 2. A of 2 is equal to some 5 or k something. But as it is a string, it cannot be modified. There are some of the library functions that are related to string. String length, string copy, string concatenation, string compare. All of these are present in string.h header file. Now, if I want to get the length of this string, I can just write it with the help of this library function, string length of a. This actually returns me the length of the string. String copy actually copies a string from target to source. So, whatever string which is present here, that will be copied to this source. String concatenation will be actually appending this target string to this source string. Let's say, for example, if the source string is ABC and if the target string is DEF, then if I write the statement, the source will actually become ABC and DEF. This is actually concatenated at the end of the source string. Now, if I want to compare two strings, I can write it with the help of string compare statement. This actually separates each and every character individually from source and target and returns the value accordingly. If both of them are equal, then it returns 0. If the source is greater than target, that means if the ASCII value of source is greater than target at that particular location, then it returns a positive value or negative value accordingly. After trying to understand strings, let's see how the input and output of strings generally happens. I have defined a main function and I have defined a character array. I am asking to enter the name. Suppose, for example, if I have entered the name as Gupta. Now, this I have entered through keyboard. When I have entered, it will actually store the name as Gupta, and name is a character array. And if I am printing, I can print it with the help of the same thing. One thing you need to observe here is, this is the program for taking input for a string and this is the program for taking input of an integer. Here, while I am taking input of an integer, I have to use address of the operator, and here I have not used it. Actually, it is not mandatory to use address because we know that this string is actually character array. And array name is mnemonic, which actually represents its base address. Even though when you specify the name of the array, in this case it actually is converted to address. So if you specify the address or if you don't specify it, it does not make any difference in the case of strings. Let's try to solve an example of strings. I have defined a string and I have made a pointer and I am making the pointer point to the first location of the array. So the pointer is actually pointing to this location. Let's say it starts with 100, 101, 102, 103 and so on. Now I am trying to print the string at this location. So it actually starts with this and it goes on till it encounters a null character. In this case, the entire string will be printed. Now let's observe this statement. Here I am trying to modify the value of the array. We know that scaled operations are performed in array. So this is transformed as 100 plus 3 into 1, as it is a character which points to the location 103. It points to this location and it is trying to print the string. Now from this location till the place where it encounters this null character, it prints it. The output of this will be THA. Now I think you got the significance of a null character. It generally starts from the location and it goes till where it encounters null character. It don't tend to print null character, but it marks the end of the string. Suppose I have an integer array which is declared over here. For the sake of simplicity, I am taking the size of integer to be 1 byte. If I want to access this location, it can be accessed with this. A actually has the base address 100 plus 3 into 1 in this case, which translates to 103. This can also be obtained by indexing and using an ampersand operator before it. If I want to get this content, we know that I need to put a dereferencing operator before it, and it can be performed with the help of this operation, or it can be even associated with its index. Now if you are having an integer pointer, you made the pointer point to the first location of the array. So pointer is actually pointing to this location. You can actually get it with the help of p plus 3, which actually moves the pointer to this location, and if you want the content, you can put a dereferencing operator before it. You need to understand one more thing. In the case of array, if a of 3 is present, then it is equivalent to content at this location. But in the case of pointer, if p of 3 is present, then it is equivalent to p plus 3. So in the case of arrays, when I represent with the help of index, then it is equivalent to the content. But in the case of arrays, when I specify like this, it is equivalent to content. But in the case of pointers, when I specify with p of 3 indexing, then also it represents address, as pointers are capable of storing only the address. So p of 3 actually translates to p plus 3 if p is a pointer, and a of 3 actually translates to content at a plus 3 if it is an array. Just try to remember this content and you can solve anything very easily. Now let's try to understand one point very clearly, that is, arrays are actually stored in continuous memory locations, and when you pass array as an argument, you are generally passing its address. Why? Because it is a mnemonic which actually stores its address. So the value is modified as it is happening through call by value, and the value here is address, which is generally called by call by reference by many people. Now to understand this quickly, when you try to pass array as an argument in any program that you have written, it will actually be modified even though if you pass it as a local argument. Before I bid you goodbye for today, I want you to ask you one thing. We have written a lot of code and most of the time we have worked with printf and scanf functions, right? Have you written the code for them? Who knows? Let's try to check it out in next week.